Hi, this is Mrs. Kidman, and in this video, we are going to be talking about similarity transformations. So when we talk about transformations, what that means is we kind of have a different list of different types of transformations that we see with figures. So oftentimes we will see something called a reflection, which is where something is taken from one side. So say we have this triangle that looks like this, and it's reflected across a certain point and looks the same way on the other side. We have a translation, which is where we move that shape. So we'll have something like this, and it'll end up moving to here, something like this. So we take it, it's the exact same size, it's just moved. We have something called a rotation, which is where we rotate our figure to a different place. So oftentimes we'll rotate it like if I rotated this one 90 degrees, then it would rotate like this. And then we also have something called a dilation, which is what we talked about in the previous video, which is where it actually changes its size and goes from bigger to smaller. So what we're going to do is talk about how we can make these transformations of triangles to show, or different polygons to show that they're similar. So let's take a look here at this first one. So we're going to graph triangle ABC with the vertices A is at -4, 1, B at -4, 2, C at -2, 1, and then find the image of what it looks like after we do that similarity transformation. So I'm going to start here with this blue one, or with purple, and we're going to graph triangle ABC here. So I'm going to go to -4, 1, -2, 2, and -2, 1. Perfect. There is our cute little triangle A, B, C. Now what we're going to do is we're going to actually transform this to a different place. Now when we do translations and dilations and things like that, it'll give us directions on what it does. So I love this example here because these ones will tell us if this is my point XY, this is what I'm going to do to those points to find the new one. So what I'm going to do is I'm actually going to do them step by step. So I'm going to translate it first and then dilate it. You can also do it in the reverse order, but sometimes translating and moving it first helps. So I'm going to do in green our intermediate one, which is just where it's translated. So I'm going to take each value and move it over once. So when I translate it, that means that our A prime is going to be -4 + 5, which is 1, and Y + 1, which is 2. And then our B prime is going to be when X goes up 5 and Y goes up 1. So this will go up to 3, 3. And our C prime will go up to 3, 2. Okay, so then as we plot this on here, I'm going to plot the point 1, 2, the point 3, 3, and the point 3, 2. Perfect. So now you can see that this green triangle is just what happens with that translation. I'm going to call this A prime, B prime, and C prime. Now that prime means I've moved it once. Now this last time what I'm going to do is I'm actually going to do the total thing in blue. So what I'm going to have here is I'm actually going to list it as A double prime, B double prime, C double prime, which means I've moved it not once but twice, and this is my final place. So what we're doing here is we're actually dilating it. So we're going to multiply everything by 2. Or it's going to have a dilation of 2. Now remember, if our dilation is bigger than 1, either the absolute value of that dilation is bigger than 1, then it's going to enlarge. If it's between 0 and 1, then it's going to reduce. So because 2 is bigger than 1, this one is going to enlarge. So let's take a look at these new points here. So if I multiply 1 by 2, I get 2, and 2 times 2 is 4. We multiply that 3 times 2, and we get 6 and 6. And then our last C prime is going to be 6, 4. Okay, so now let's graph this one last time. We've got the point 2, 4 here. I've got the point 6, 6, and I've got the point 6, 4. So you can see here that we've moved it 3 times, and this is our final triangle, A double prime, B double prime, C double prime. And we can see that it moved. This was our original triangle here in purple, and it both went over, it went up, and it enlarged. So we actually did multiple transformations here all at once. So what we're going to do in this video is we're going to look at what happens every time we transform it. And we're just going to do a couple of examples so that we can look at these different types of transformations. Now this next one here involves a rotation and a dilation. So when we rotate, we want to start with our original problem. Now notice how it says that we're rotating about the origin. What that means is this is our center point. And so if I have my shape here like this, it's going to rotate 90 degrees this way as if it's like connected to this. Do you see how this one's negative over back to up 1? That means our new one is going to rotate 90, or it's going to switch up to over 1. So it's going to be pretty cool. But let's start by graphing our line here. So we've got this line segment with the endpoints negative 2, 2, and 2, 2. So I've got negative 2, 2, and I've got the point 2, 2. Perfect. So here is where we are at. Now we need to rotate this 90 degrees about the origin. Now when we rotate 90 degrees, really what that does is notice how here our x values are, we've got a negative x and a positive y. Well, if I want to rotate it 90 degrees, these ones are x, y. So what we're going to do is we're going to switch the signs on the x value, but not on the y value. So let's take a look and see what happens when we rotate this. So I'm going to switch the sign on this first one. So it's going to go from a negative 2 to a positive 2. And then the other one will stay the same. So we'll be right here. And then we'll switch the sign here, negative 2. Oh, no, we won't. We're going to rotate it. It'll go like this about the origin. So that means that this piece, instead of being here, is going to be here. And this piece is now going to be here. Do you see how it looks like we just took this piece here? It feels like we just took this piece and we rotated it 90 degrees over here. That's what we're doing here when we talk about rotating our origin piece. That's what we're going to do. Pretty cool, right? Okay, so we've rotated it now. Now what we're going to do is we need to dilate it. So when we dilate it, what we're going to do is actually multiply each piece by 1/2. And so we've got our pen here. So we've got our points negative 2, 2 is our original one, and our other one is 2, 2. And so as we adjust this to our blue one, what we're going to do is have half of that. So this would be a negative 1, 2, or negative 1, 1, and a 1, 1. But remember, we've rotated it. So actually, it's just going to go right here. Okay, so this is our final one there, is that negative 1, 2. So again, our purple one here was our original one that was right here. Then we rotated it 90 degrees. Oh, not that far out. So we had it right here. We rotated it 90 degrees, so it became there, and then it got reduced. And that's how we do that. Okay, let's take a look at one last example. In this case, we're going to actually reflect across the x-axis. So as we're reflecting here, that means we're just going to flip across whichever axis we're talking about. So whatever our positive y value is, we'll switch it with the negative one, things like that. So let's take a look here and graph our first triangle. So with our triangle here that has vertices at 1, 2, at 4, 4, and at 2, 0. So here's our first triangle. Fantastic. Now what we're going to do is we actually want to reflect it across the x-axis. So I'm going to take it and move it over here. So what happens when we reflect is that our x value across the x-axis, what happened is our x value stays the same and our y value is going to change. So instead of it being at 2, 0, we want the opposite of 0, which is still 0. But this one will go down to here, and this one will go down to here. And so our new triangle is going to be down here. Now notice how it's flipped, mirrored, exactly across that x-axis. Then the very last thing we're going to do is we actually need to dilate it, and we're going to use green to do this dilation. So notice our new points here, our f prime, our g prime, and our h prime. So our new points that we have is our h is still at 2, 0. But our g value is now at 4, negative 4, and our f value is at 1, negative 2. So then we want to dilate these new values here. So our f double prime, our g double prime, and our h double prime are going to be when we have those other points and we multiply them by 1.5. So our f double prime is going to be 1.5, and 2 times 1.5 is going to be 3. And then we've got our 4 times 1.5, which is 6, and a negative 6. And then our last one here is going to be at 3, 0. So then as we plot this on here, I'm at 1.5, 3. 1.5, negative 3. That would make more sense. We are at 1.5, negative 3. We are at 6, negative 6. And we are at 3, 0. So it looks right here. So these ones kind of overlap here, but that green one we can tell was enlarged compared to that reflection that we originally had. So the blue one is our original one. And after both these changes, we ended up with the green one. Pretty cool. Okay, let's take a look at one last example, or at one more type of example here. Now, in those previous ones, we were given something and we need to describe what it did. In this case, what we're going to do is we want to describe a transformation that will then take this trapezoid to become this one. So let's take an example first. What did it do to go from here to here? Well, it looks like it reflected across the y-axis, right? And a very easy way to tell that we've reflected it across the y-axis is you can actually see that it's facing the opposite direction. So when it faces the opposite way, we've reflected. Now, once we know that we've reflected, what we want to do is figure out what is that dilation rate that we're looking at, or that dilation factor. And so what we have here is, notice this length right here, this YZ is 2. And this one right here, this SR, is actually 1, 2, 3, 4, 5, 6. And so because SR is part of our original trapezoid, and we want to map that or put it onto this new green one, what we need to do is describe how does it get there. So our original one was 6, and then it shrunk to a 2. Similar here, we had a 3 that shrunk to a 1, and a 6 that shrunk to a 2. So it seems like our factor here, or that K, is going to be 1/3, right? And the way we can figure that out is the new one divided by the old one. So 2/6, or 2/6, or 1/3. So that dilation is by a factor of 1/3. So to get it from the blue trapezoid to the green trapezoid, what we have to do is reflect across the x-axis and then actually dilate it by a factor of 1/3. Now let's take a look at one point here and see if that will work. So let's take a look at the point R. So say we had our original R value. So that one is the point 0, -3. If I reflected that across the x-axis, we would get 0, -3. And then if I multiplied that by a factor of 1/3, I would end up getting the point 0, -1. And bam, that's where we're at. Now you can check all 4 points here to see if that process works. Otherwise, we can just kind of observe it. So that's another way that we can use this similarity to keep it in mind. If we have something that we're given, we can transform it. If we're given a transformation, we can look and see what did it do to go from the original one to the other one, and write down those steps. And we can always take a point and have it follow through those 2 steps to make sure that we get to the right place. But that is how we can look at similarities of different figures when they're in a coordinate plane to decide what their transformations are and if they're still similar after those transformations. And so that's something really important to keep in mind, is to ask ourselves, are they still similar? Well, if they are, things aren't going to change and I can follow these steps. If you have any questions, feel free to reach out, but that is how you can determine similarity transformations of figures.